In a simple limiting reagent problem, 55 grams, this is iron with sulfur makes iron 2 sulfide. Molar mass of sulfur 55.85, molar mass of iron 55.85, molar mass of sulfur 32.07, right? So you can make this amount of product just by using the stoichiometry, the setup of the reaction. Let's say that I don't have 32 grams of sulfur. Let's say that I have 40 grams of sulfur, a little bit more. How many grams of product I'm getting? 87.92, the same amount, because in this case, 55.85 iron is my limiting reagent. All of the iron will be used up, and 40 minus 32, like almost 8 grams, will be left over. If I have 55.85 grams of iron, but I have 1,000 grams of sulfur, I don't care. I'm still getting the same number of grams of product, because iron is my limiting reagent. It limits the reaction, okay? 32.07 grams of this 1,000 will be used up, and the difference, 1,000 minus that, will be left over unreacted, just sitting there in the reaction. Good? Yes?
So like if we reacted those together, we'd literally have FeS and just sulfur in there.
Yes, you're gonna have product, this amount, and let's say you react this, and you're gonna have 978 whatever grams of S of sulfur floating in there, basically. That's what it's gonna be.
Whatever the low, you said whatever the smaller number is the
When you-
limiting reaction?
Yeah, so when you do that, this is just an example how the math works for the limiting reagent. You're gonna get the same smaller amount, the same amount, it doesn't matter how much of the excess reagent you have.
Okay.
But when you do the math, and you have like a stoichiometry problem with limiting reagent, you have to do the math twice,
Yeah.
okay? And you are going to choose the smallest amount of product that you calculate, okay? Good with this? All right, let's see. So this is another limiting reagent problem, and I want you to look at it. So iron and sulfur make iron sulfide. This is very simple, easier than what we did so far. And the problem says, how many grams of iron sulfide can be made if 10 grams of iron and 10 grams of sulfur are mixed and are reactive? So 10 and 10, they choose the same number out of choice, not because it has to be the same. Look, in this case, you had 80 and 120. Doesn't have to be the same number. So step 1, balance the reaction, blah, blah, blah. It's already done. Step 2 is, or step 3 is make your grams into moles, right? So you take 10 grams of iron and you turn them into moles. You have 0.179 moles of iron. And if you use the iron to calculate FeS, because it's a one-to-one reaction, you're gonna get the same number of moles of FeS. Right? You with me? Okay. Now I'm gonna do the same thing with sulfur. It would be really great if this thing would work. For sulfur, I have 10 grams of sulfur. Here, sulfur is not Fe. I have to fix that. You make them into moles. That's your step 3, and you get this amount of moles of sulfur. And then, because it's a one-to-one between sulfur and iron sulfide, you are going to get 0.312 moles of iron sulfide. And now you compare. What did you have on the previous slide in terms of moles, and what do you have here in terms of moles? I wish this. So basically, if all the iron reacts, you get 0.179. If all the sulfur reacts, you get 0.312 moles of the same product. And you choose the smallest number. The 0.179 is the right answer, and that is called your theoretical yield. Based on the math, that is, and I don't know if it's a little bit counterintuitive, but the theoretical yield is the max, even though it's the smallest number that you pick from your calculation, that is the maximum amount of product that you can make. You cannot make more than that, even if the math says that here, I can produce a little bit more. No, you can't. because you don't have enough iron, which is your limiting reagent. So iron becomes your limiting reagent, and your sulfur is your excess reagent. Good? So the maximum amount of iron sulfide is 0.179, and you turn it into grams by multiplying by the molar mass, and you get that 15.7 grams of FeS, that being the theoretical yield. Now let's look what do we have. If you think about what reacted. Iron is your limiting reagent. It goes in, all of it. Consumed, all the 10 grams that are given to you are used up. And then 15.7 grams of FeS is produced. We just calculated the theoretical yield, right? Now, because the law of conservation of mass has to be obeyed, how many grams of sulfur are we going to use for the reaction? 15.7 minus 10 gives me the 5.7 grams are used. That's how much is used, okay? Now how much is left over? Sulfur is your excess reagent. Out of the 10 grams, 5.7 are used and 4.3 grams are left over unreacted. So at the end of the reaction, you're gonna have 15.7 grams of product and 4.3 grams of excess reagent, which is sulfur floating around in there. Okay, so that's the way you have to kind of understand this limiting reagent problems. So again, when you solve it, you do the math twice. Apply the stoichiometry calculation twice and choose the smallest amount of product. You have to choose at the mole state in step 4. Once you chose the smallest amount, that smallest amount you convert it into grams. You don't need to do step 5 for both of them and look at the grams. That would be more work for you. Okay. Choose the smallest number of moles, and that number of moles go with it for step 5 and convert it into grams if the grams are required. Good so far? Okay. Bear with me 1 second. This is not going to do whatever I need to do. Hold on. These are more examples. We have a ton of examples here. What I want us to talk about now is the percent yield. So let me look at this problem. Let's revisit this problem a second. So, I am producing 142 grams of sodium sulfate. That's how much I'm producing from this reaction. Now, this is called my theoretical yield. This is your theoretical yield. And let me amend the problem. Let me add something to the problem. So based on my math, if everything goes perfectly, I am producing 142 grams of sodium sulfate product. Theoretical yield. The yield refers to products. The reactant, limiting, and excess refers to reagents, reactants. So theoretical, so let me erase here. So I'm going to add something to the problem. I want to say this: if 150 grams of Na2SO4 are produced, find the percent yield. So what is the percent yield? The percent yield is how much stuff can you make in reality given that it's not a perfect world. You want to make cookies. On the package says that if you put these cookies the way they are in the oven, they're 12 cookies. And your oven burns half of them and you make 6 cookies and 6 are unusable, throw away. What's your yield? It's a 50%, right? So the same thing happens. If it would be a perfect world that everything goes at 100%, your percent yield would be 100 and you would make 142 grams of Na2SO4. For you to calculate the percent yield, the actual yield has to be given to you in the problem. The actual yield has to be given to you. And what I just added here to the problem, this 115 grams of product, this is your actual yield. AY, abbreviation. And this is your theoretical yield. Theoretical yield, you calculate it, is the smallest amount that you can produce, the smallest number that you pick with a limiting reagent, and the actual yield has to be given to you. So when you divide the actual, the smaller number, over the theoretical, which is always bigger, times 100, you're gonna get your percent yield of the problem, of the reaction. So you're, in this problem, if I am to erase here, my theoretical yield is 142 grams of Na2SO4. The actual yield is given to me at 115 grams of Na2SO4, so the percent yield will be 115 over 142 times 100. No idea how much that is, we can calculate it.
80.9%.
80.9%. Okay, so that would be if I am asking about percent yield. That means I have to give you your actual yield for you to be able to, and the theoretical yield, you can always find it from the reactions. Good? All right. So you can cut the video because we are done with this part.